with the help of a thread class. So I'm going to take similar workspace, and I have just deleted all the data, previous data. And what I'm going to do is I'm going to create a class that extends the thread, that is class extends the thread. Inside it, however, I have to write public void run method, and then I'm going to take the similar functional part, that is int I, and I will implement the for loop for it, and I will be starting from 0 and will end till 5, and then I plus plus. After that, system.out.println method, and it will display the result, and the result will be first I in the double inverted commas. I should have to put some spaces for I equals to, and then concatenate I inside both of these display sections. So I have given I equals to plus I plus thread x, and I will copy whole section, and I'm going to write it for y class, that is extended as thread, and going to do similar for the third class, that will be z. And I have to just change the uh, name of the thread I have given in the system.out.println method. Inside the main section, what I'm going to do is I'm just going to create the object. So how the objects are going to be created, it will be like this: x a equals to new x, and then similar for the y, b equals to new y, and then z, c equals to new z. So these are for the three classes I have given above, and then a dot start method, similar for the b dot start method, and similar for the c dot start method. So you can see I have created three classes and written the run method in each of it, and given some functionality to iterate at, and to display how these threads are going to be implemented using thread class. And then in the main section I have created object, and then given the start method. So run it as you can see below, that x has been started first, then y z, y x, y, and then y is finished here, z x x, z z x, and you can see z is finished first and then x. In the second execution, you can see y started first, then z, then x. Then you can see z has finished first, then y, then x has finished first. In the third execution, it has changed again. X has started first, z has started second, y has started third, and you can see that z has completed first, and then x, and then y. So this is how you can create a thread using thread class. So we have some problem statement related to it. This is going to be the experiment that you are going to do. So this is the problem statement 19. So what does this statement says? Write a multiple multi-threads that creates two threads, one thread with the name CS thread and the other thread named IT thread. Each thread should display its respective name and execute after a gap of 500 milliseconds. Each thread should also display a number indicating the number of times it got a chance to execute. Let us look at the theory of this program. So the theory says public class thread. A thread is a thread of execution in a program. The Java Virtual Machine allows an application to have multiple threads of execution running concurrently. Java provides a thread class that has various method calls in order to manage the behavior of threads. So this is some kind of a hint that has been provided to you for your experiment, and you have to do this experiment and send it to me in yuvrajjoshi@gu.ac.in. This is the first program, first experiment of this thread creation in Java, and now we are going to look at the second experiment you have to do. The problem statement 20. Problem statement: write a Java program for to solve a producer consumer problem in which a producer produces a value and consumer consumes the value before the producer generate the next value. I'm going to read it again. You have to understand, guys. Write a Java program for to solve producer consumer problem in which a producer produces a value and consumer consumes the value before producer generate the next value. Now we are going to look at the theory section of this experiment. So here it is. Public interface runnable. The runnable interface should be implemented by any class whose instances are intended to be executed by a thread. The class must define a method of no arguments called run. Now, public final void wait causes the current thread to wait until it is awakened, typically by being notified or interrupted. Public final void notify wakes a single thread that is waiting on this object's monitor. If any threads are waiting on this object, one of them is chosen to be awakened. The choice is arbitrary and occurs at the discretion of the implementation. A thread waits on an object's monitor by calling one of the wait methods. So this was your theory section of the second program, second experiment I have given you. These both experiments should be done by you and has to be submitted to me before the next lab session, and then only I will accept these programs that has been done by you. As I've seen that most of the class is not seeing the video and are not getting whatever has been taught. So this is a serious trouble, guys, for you, because I don't know what is the future is going to be for you, because Java programming is one of the serious programming that you have to master and that you have to learn, because after some time you are going to be developing Android apps and some of these things, or whatever you like to do, but Java is necessary for the basic programming for you guys. So I think that you guys have got it what I want to say, and please take care, guys. These times are tough for you as well as for each of us. So wash your hands and keep it tidy, guys. So take a good care of yourself. So guys, meet you in the next session. Till then, bye bye and take care.